Hi, my name is Iqbal Khan. I am a technology evangelist at Alachisoft. Today, I will talk about how you can achieve high availability in NCache and how NCache provides you high availability. Um, as you know, NCache is used in mission critical applications which cannot afford any downtime. Here's a picture of you have an application server farm that is using a cache cluster of multiple servers, and then there's multiple data sources, and these usually are minimum of two or more cache servers. And Ncache provides you a dynamic cache clustering where you can add or remove cache servers at runtime without stopping the application, because Ncache has a peer-to-peer architecture, and I will demonstrate this in the video today. And I'm going to use the partition replica topology, where we'll start out and keep adding more servers, and you'll see in this topology, every server has one partition. So as if I start with one server, it's only one partition, and the replica is also on the same partition, or maybe there's no replica. And then as you add a second server, you have two partitions. So the entire data of the cache gets divided up half each, and each partition is replicated onto a different server. And then as you add a third server, you have three partitions, and the same data gets divided up into three partitions. Each partition has now 1/3 of the data instead of having 1/2 of the data, and each partition is backed up onto a different server. So this is what I'm going to demonstrate. Let me quickly jump into the product and show you this. I have three cache servers that I will use. I will start with one, and then I'll keep adding more. And then I have one client. I'm actually right now sitting on the client machine. So I'm going to just click on this and open the NCache Web Manager, which is a web-based management tool. And currently, this is how NCache comes when you install NCache. So as you install NCache on all these three servers, on each server, there was a demo cache that got installed. So I'm going to actually now start the demo cache, and you'll see that the demo cache is started. I will also, once it's started, I will also open a statistics on it, and I will also do monitor cache. Monitoring gives me a very nice dashboard. There's a server dashboard and there's a report dashboard. The report dashboard is very much like the statistics window. So I'm just gonna stick to the server dashboard, and I'll keep it here. And now that I have this running, I need to now run the clients. NCache comes with a PowerShell based stress test tool. So I will just, let me type the word NCache. There's a PowerShell management. So just decrease its size. Sorry about this. Okay. So I'm going to run test stress, and I will give it a name of my cache, which is demo cache, as you can see right here. The cache name is case insensitive, so you can enter it any way you like. When I start the application, this is my stress test tool. The reason this is there is so that you don't have to do any programming to start testing NCache. You can also simulate stress through the stress test tool. That's why it's called stress test tool. But just imagine this would be your application. Now, if I come on to my statistics window, you'll see that I have a count of about 400 items, and it keeps increasing. I have about 981 or to about 1,000 requests per second from that one client. I'm going to now go ahead and add a second client. So I can keep adding multiple clients by starting multiple stress test tool instances, or I'm sorry, PowerShell instances. So if I come here, I again say stress demo cache. Once I do this, you'll see that the count or the request is almost doubled now, because each client, as you saw in this picture, each client is putting its own transaction load onto the server, so the transaction capacity of the server has almost doubled. I can also see this here in the, hold on, just I can also see it here that that in my server dashboard, I have 2 clients connected to a 1 node cache cluster. So there's only 1 server in the cluster that I am using currently. Okay, I'm going to now, let's assume that what happens in real life is that your capacity grows. And by the way, we recommend a minimum of 2 cache servers, so you should never have only 1 cache server running on this. But I just wanted to start with 1 so I could add 2 servers at runtime to show you. So now the next thing I do is I'm going to add a second cache server, and the second cache server that I'm going to add is the 117. I will go ahead and 117. I will say add. It has been added, but it is stopped. So I'm going to click it here and say start. That will just start the server node. Once I start here, you'll see that a second node will get added here, there. And the cache count has dropped. I did not show you that the cache count was actually double that much. Now that it's 2 servers, the cache count has dropped. And the transaction requests per second has been divided into half, because half of the requests are being processed by this cache server, half of them are being processed by this cache server. So this is how the count has dropped. So now I've just added a cache server without stopping the application. You can see the stress test tool is running here, and it's also running here. No issues at all. And what happened now is that my partitions. So I was 1 server, now 2. Now I'm a 2 server cluster. So there's partition 1, partition 2, and every partition is backed up onto the other server. So let me show you what that is. So here's partition 1. It's got this many items, and its replica is right here. See, this is almost the same quantity as this one. And then this is my partition 2, about 1500 something, and it's backed up here. Now this replication is asynchronous, so this count will not always be exact, but it will eventually be exact, even if you stop the transaction. Okay, now let's say that my transaction load keeps on growing. My business is doing well, and I need to add more servers because I need to increase the transaction capacity. I can also add more clients, because that's what's going to happen first, is that I will be adding more clients, because the first thing I'll do is add more clients, more application servers, I mean, and that will result in a higher transaction load. Just watch, this transaction load will increase. There, see, it went to 1182 per server instead of 800 something, and actually it's gone even more. It's gone 1200 something. So the transaction load keeps on going up. I can also see it here. I can see the request per second on each server that is being distributed. As I added more servers, it is being increased. So now that I've added more clients, at some point I will need to, I will notice that my cache servers are starting to slow down because the transaction capacity is maxing out, or maybe the storage capacity of how much memory I have in each server is maxing out. So I need to add yet 1 more servers. In any case, as I said, we recommend a minimum of 2 servers. So you should never have a single server cluster in production, at least, because that does not give you high availability. So when you have minimum of 2 and you reach the capacity limit of these 2, then it's time to add a 3rd server. How do we add a 3rd server? I have a 3rd server right here, 157. I will come here straight away, and I will say add a server, and it is 157. So I will come here and add 157. Again, it is added, but it is stopped. I will come here, select this, and say start. Once I start, notice this 1800 is going to go down. Watch. As soon as the 3rd server kicks in, it will share the load. There, see, it came down to about 1100 something each, because now I have 3 servers instead of 2. And as I showed here, that when you have 3 servers, you have 3 partitions. So the data from both of these partitions gets divided up further into 3 partitions. So now each partition has a replica onto a different server, and that's how the data is actually distributed. This is basically, it is, so I've just demonstrated that you can add more servers without stopping either the application or the cache. So everything is, I mean, the application is totally uh, unaffected by this change, by your adding more servers, which is a great thing about NCache, that it lets you do that. Okay, so now there comes a time maybe you need to also bring a server down. There are two ways that you can bring a server down. One, you're bringing it down permanently because you are reducing your capacity. Maybe you're coming down from 3 servers to 2 because it's a seasonal business. You had a peak usage time during the holiday season, and now again you're going to go back to your default smaller configuration. So some of these servers are going to be actually removed. So let's go ahead and do that. I'm going to remove server 157 in this. So I'm going to pick server 157 and I'll say stop. First I will do stop. Now as you can see, as I'm stopping, this count will go down and this count will increase further. See, it has gone to about 2000 each again. That means the data has shifted from this onto this. I have basically gone from 3 partition configuration to a 2 partition configuration. And each partition is replicated. As you can see here, each partition is, so this partition is replicated right here, and this partition is replicated right here. Okay, and no effect on the application, as you can see. So that pretty much handles the situation where you need to either add a server because you need to increase capacity, or you need to bring a server down because your capacity need has changed. It has actually, because of the seasonal use, the capacity need has changed. Okay, there's another situation, which is what we call maintenance mode, where you need to bring a server down, but not because your capacity has gone down, is because you need to do some maintenance. Let's say you need to apply some operating system patches or something. So you need to bring a server down for maybe 5 minutes, 10 minutes, half an hour, something. But your cache has got huge amounts of data. I mean, our customers, they have tens of gigabytes of data in each server. So if you have a 3, 4, 5, 6 server cluster and a combined, data of tens of gigabytes in each server, bringing a server down actually impacts performance, because now if you had to repartition everything to go from 3 partitions to 2 partitions, you're going to do a lot of state transfer, and then for what? Again, to add it back. So we came up with a feature called maintenance mode, where you can tell NCache that, okay, I'm bringing this server down, but I don't want you to repartition the cache. Keep this as a 3 partition node. So partition 1, partition 2, and the replica 3, which is right here, will become partition 3. And this stays active. It's a temporary arrangement. At the end of it, once you're done, you'll bring this node back up and it'll be back to this picture again. Let me show you how you can do that. Okay, so I will first of all again achieve the 3 server configuration. I'm going to add this. Well, assume that I had removed it. Now I'm adding it back. I should have removed it. I only stopped it, but I am going to add it back. I am again on a 3 node cluster. My data is evenly distributed. My transaction load is evenly distributed. And I can see it also here. Actually, this is not showing it yet. It will, but anyway, so once I have this, now I need to do maintenance. So I'm going to come here and I will say, okay, again, remember that each node has about 1200 items each. Okay, so if I were to bring it down to a 2 node cluster, this should go up to 2000 plus items in each node, which is not what is going to happen, because I'm going to come here and I will say here, I'll say stop this for maintenance. When I click on this, it asks me for how long do you want to keep it in maintenance. Obviously this timeout is very important, because at the end of that timeout, NCache assumes that it's no longer maintenance, because if you don't add the node back by this time, NCache assumes that you have actually removed it permanently, like the other remove that I had just shown you, and it will actually remove and repartition the cache. But if you add it back within this time period, and it's a configurable time period. If you add it back within this time period, then NCache will do what I just showed you, that it will not repartition, it will just keep that partition, that replica in a temporary partition mode. So let me just say, okay, I'm saying stopping this now. So let's come here, 1300, 1300, 1470, and now this is completely gone. But notice this count has not gone up. Why? Because one of the replicas has become active partition. You don't know which one through this picture, but the fact that the count has not gone up, the replica is still there. This replica has become an active partition. So now server 1 has partition 1 and partition 3. Server 2 has partition 2 and a passive replica 1, and server 3 is down, which I need to do. I need to bring it down for maintenance. So now you go and you do your maintenance, you apply your patches, and now you're done. Now you want to bring it back up. So again, you just come here. Now you say add it again. You don't even need to re-add, just say start again because it was stopped. And by the way, in all of that the application was still running without any interruption. So all those changes do not require any application interruptions. So I'm going to say start again. And once I say start, now watch, this will regain its position, and it's again catching up with the data. And you'll see that again, it's again at the same level that it was previously. So as you can see, I have demonstrated both adding and removing nodes at runtime in a permanent basis, and also temporarily removing a node for scheduled maintenance basis. So that is the end of my demo. I had hoped to demonstrate to you that NCache, it gives you high availability. It's 100% uptime, where you don't have to bring any of the application down. There's no interruption in the application. Thank you very much.